OpenInspect is a hosted background coding agent inspired by Ramp's Inspect. It lets developers focus on other work while tasks run silently in the background. The agent has access to full development environments, including Node edges, Python, Git, browser automation, and Visual Studio Code. You can connect to it from a web UI, Slack, GitHub pull request comments, linear issue comments, or even via webhooks. It also supports multiplayer sessions where several people can collaborate in real time, generates pull requests with the correct commit attribution, schedules jobs with cron or Sentry alerts, and can spawn multiple subtasks that run in separate sandboxed environments simultaneously. Users may choose from a range of AI models, such as Anthropic Claude, OpenAI Codex, through a ChatGPT subscription, or OpenCode Zen. The system is designed for single-tenant deployments only. All users must be trusted members of the same organization that has access to the same code repositories, because it relies on a shared GitHub app for everything that touches Git, cloning, fetching, pushing. The same app credentials are used for every user. The system does not check whether a particular user has permission to read a repository before opening a session. When users log in with GitHub, their OAuth token is used to create pull requests so that the PRs are correctly attributed, and the user can only push to repositories they can write to. If someone signs in with another provider, such as Google, her token does not provide SCM access, so her pull requests fall back to the shared GitHub app bot. The token architecture can be described as follows. The GitHub app token is used for cloning, fetching, and pushing from any repository where the app is installed. A user's OAuth token is used to create PRs and obtain basic user information. Sandbox authentication tokens establish a session between a sandbox and the control plane for a single run. WebSocket tokens provide real-time session authentication. Ramp's Inspect is the inspiration for this architecture. The original design was built for internal use within a single company, so it assumes all employees are trusted and all repositories belong to that organization. For a multi-tenant deployment, you would need separate GitHub app installations per tenant, validation of repository access when a session is created, and isolation of tenant data in the data model. When you deploy OpenInspect, you should keep it behind your organization's single sign-on or VPN connection to prevent unauthorized access. Install the GitHub app only on repositories that the service needs to reach. Restrict who may sign in by configuring allowed GitHub users, domains, or organization membership. Finally, when installing the app, choose specific repositories rather than the default all repositories scope. The architecture of the deployment can be understood in two main parts, the control plane and the data plane. The control plane is housed in Cloudflare workers and uses durable objects for each session. Within each durable object lies a small SQLite database as a session store, a WebSocket hub for real-time traffic, an event stream, and a GitHub integration module. There is also a D1 database that stores secrets scoped to each repository. Below the control plane runs the data plane, the sandbox backend. Each session sandbox contains a supervisor, the OpenCode agent runtime, and a bridge that forwards the agent's output back to the control plane. The sandbox itself runs a full development environment with Node.js, Python, Git, a Chromium headless browser, and optional VS Code served via Kata server. The sandbox also supports browser automation, a web terminal, port tunneling, and confidential secrets that are injected as environment variables. OpenInspect ships with a set of packages. The control plane package runs on Cloudflare. A separate web package implements an Next.js frontend. The sandbox runtime package contains the runtime code that runs inside each sandbox. There are also packages for Modal and Daytona Cloud Sandbox infrastructure, a Slack bot for starting sessions from messages, a GitHub bot for auto review, a linear bot, and shared utilities. The quick start instructions for developers are in the Getting Started section. The first step is to read the local setup guide, then read the deployment instructions, the core architecture guide, and the automation guide if you want to run recurring tasks. Key features include fast startup. After a prompt is issued, the sandbox is either restored from a snapshot or a pre-built image. Images are pre-built for each repository and updated every 30 minutes. The sandbox also warms up as soon as you begin typing, so it starts running before you press enter. Multiple repositories can be worked on in a single session. When you start a session in the picker, you can choose up to 10 repositories. The agent can clone all of them side by side and can commit to each one separately, opening a pull request for every repo. You can also save a set of repositories as an environment that includes its own secrets and optional pre-built image. The environment can be launched from the picker just like a single repository. The agent supports multiplayer sessions. When several people join the same session, the interface presents indicators. Each prompt is attributed to its author in Git commits. All connected clients see real-time streaming of the agent's output. Commit attribution works by configuring the Git identity for each prompt. The agent calls a routine that sets the author name and email to that of the prompt's author before making any commits. Model support is multi-provider. You can choose Claude models from Anthropic, GPT and Codex models from OpenAI, or OpenCodes and models such as Kimi and Qwen. The OpenAI models are used through your ChatGPT subscription, so no separate API key is required. A full list of supported models and how to enable them can be found in the documentation. The agent can be interacted with from several client integrations. The web UI offers full session management, real-time streaming, model selection, a terminal panel, and multiplayer presence. The Slack bot can be launched by mentioning or by sending a direct message. The bot replies with results and remembers user preferences. The GitHub bot runs auto review on pull request creation or replies to mentions and comments. The linear bot can be triggered from an issue to start a coding session, post progress, and link the resulting pull request. You can also trigger sessions from any system using authenticated HTTP post webhooks. Automations let you schedule tasks or react to external events. You can set cron schedules with time zone support, listen to Sentry alerts for new errors, filter inbound webhooks to decide whether a session should start, and run a single automation across multiple repositories. The system automatically pauses after 3 consecutive failures and keeps a full run history. A dedicated automation documentation page shows how to set all of this up. The sandbox environment supports a pre-installed stack, Node.js 22, Python 3.12, Bun, Git, the GitHub CLI, and build tools. A Chromium-based headless browser is available for screenshots, visual diffs, and UI tests. An optional Kata server gives you a browser-based VS Code attached to the workspace. A web terminal powered by TID is accessible from the session UI. You can expose up to 10 development server ports via encrypted tunnels. The tunnel URLs are provided inside the sandbox for a short period. Secrets are stored with AES 256 GCM encryption and can be scoped globally, per repository, or per environment. They are injected as environment variables when a sandbox starts. Subtask spawning allows the agent to decompose work. When you call the split-task function, a child session runs in its own sandbox and the parent session continues. You can query the status of a child with task status or cancel one with cancel task. There are depth limits and peer repo guardrails to keep resource usage under control. Repositories can optionally provide a pen inspect folder with 2 scripts. The setup sh script runs when an image is built or a new session is created. It can install dependencies. The start sh script runs every time a non-build session starts and should bring the application up. If setup sh fails, the system ignores the failure for fresh sessions but crashes for image builds. If start sh fails, the session fails immediately. Default timeouts are 300 seconds for setup and 120 seconds for start. Both scripts receive an environment variable indicating their boot mode. OpenInspect is released under the MIT license. It is inspired by Ramps Inspect and built with Modal, Daytona, Versal Sandbox, Open Computer, Cloudflare Workers, OpenCode, and Next.js.